Good day, Grade 9 learners. Today, we will explore the concept of uniformly accelerated motion. Uniformly accelerated motion, or UAM, refers to the motion of an object where the acceleration remains constant. In this type of motion, the velocity of the object changes at a constant rate over equal intervals of time. UAM occurs when an object experiences a constant acceleration. The rate at which its speed changes is constant, either slowing down or speeding up at a steady pace. There are two types of uniformly accelerated motion. The first type of UAM is characterized by its horizontal dimension. The horizontal dimension refers to the direction perpendicular to the force of gravity. It typically represents the x-axis along which motion occurs horizontally, from left to right or right to left. Unlike UAM in vertical dimension, acceleration in the horizontal dimension is not directly affected by the Earth's gravity. The second type of uniformly accelerated motion is the vertical dimension, also known as free fall. It is a concept where objects are influenced solely by Earth's gravity as they move either upwards or downwards. In this scenario, objects experience a constant acceleration of 9.8 meters per second squared, showcasing the direct impact of gravity on their motion. Vertical UAM simplifies the understanding of how objects move under the force of gravity, highlighting the consistent acceleration experienced in free fall. Examples of uniformly accelerated motion are a car moving along a straight road, a skydiver jumping out of an airplane, an elevator moving upward, and a book fell on a table. How to compute UAM in horizontal dimension? It is important to remember that the acceleration in horizontal dimension is not directly affected by Earth's gravity. The acceleration can come from engines and others like force. Therefore, the value of acceleration is not constant, like the acceleration due to gravity in vertical dimension. In computing UAM, the following formula can be used to compute the horizontal dimension. Number 1, v or velocity, is equal to distance or d, divided by t or time. Second, average velocity, is equal to final velocity, or vf, plus initial velocity, or vi, divided by 2. Third, acceleration is equal to final velocity, or vf, minus initial velocity, or vi, divided by time. Fourth, distance or displacement, or d, is equal to final velocity, or vf, plus initial velocity, divided by 2 times time or t. Fifth, distance or displacement, or d, is equal to initial velocity, or vi, times time or t, plus 1/2, or 0.5, times acceleration, or a, times time squared, or t squared. Lastly, final velocity squared, or vf squared, is equal to initial velocity squared, or vi squared, plus 2, times acceleration, or a, times distance, or displacement, or distance, or d. In solving UAM problem, it is important to take note of the variables, symbols, and units given in the problem. For acceleration, the symbol is a, the unit of acceleration if meter per second. Meter per second is the unit of initial velocity, or vi, and final velocity, or vf. However, the unit of time is seconds, or s, while for displacement or distance, the unit is meter. Okay, now, let us have a sample mathematical problem for horizontal dimension using GRACE method. GRACE means G for given, R for required, E for equation, S for solution, and A for final answer. Example. An airplane from rest accelerates on a runway at 5.50 meters per second square for 20.25 seconds until it finally takes off the ground. What is the distance covered before takeoff? First, encircle the given in the problem. The word rest in the given problem means that the initial velocity of the airplane is 0 meter per second because it is not moving. 5.50 meters per second squared is the acceleration. 20.25 seconds is the time. So, the given r, initial velocity, or vi is equal to 0 meter per second, acceleration, or a is equal to 5.50 meters per second squared, and t is equal to 20.25 seconds. The required or what is being asked in the problem is distance or d. The equation to be used is distance or displacement or d is equal to initial velocity or vi times t or time plus 1/2 or 0.5 times time squared or t squared. For the solution, all you have to do is substitute it. Therefore, the final answer is distance, or d is equal to 1,127.67 meters. Let us have another sample problem. A jeepney from rest accelerates uniformly over a time of 3.25 seconds and covers a distance of 15 meters. Determine the acceleration of the jeepney. First, encircle the given in the problem. Again, the word rest means that the initial velocity of the jeepney is 0 meter per second because it is not moving. 3.25 seconds is the time, and 15 meters is the distance. Thus, the given in the problem are, vi is equal to 0 meter per second. Time or t is equal to 3.25 seconds, and distance is equal to 15 meters. The required or what is being asked in the problem is acceleration. The equation to be used is acceleration or a is equal to distance or displacement or d minus initial velocity of vi times time or t divided by 1/2 or 0.5 times time squared or t squared. For the solution, all you have to do is substitute it. Therefore, the final answer is a is equal to 2.84 meters per second square. For vertical dimension, it is important to note that objects that are thrown or move upward always experiences a constant acceleration of 9.8 meters per second squared due to gravity. The acceleration is positive when the object moves upward, and negative when it moves downward. Let us now have a sample problem for vertical dimension using Grace method. Z is playing with a ball on top of a building, but the ball fell and hits the ground after 2.6 seconds. What is the final velocity of the ball just before it hits the ground, and how high is the building? Again, first, encircle the given in the problem. The ball on top of the building means that the ball is at rest and not moving, therefore, the initial velocity of the ball is 0 meter per second. When the ball fell, the acceleration of the ball due to gravity is negative 9.8 meters per second. 2.6 seconds is the time. The required, or what is being asked, are final velocity, or Vf, and height, or h. For the equation, final velocity, or Vf, is equal to initial velocity, or Vi, plus acceleration due to gravity which is constant, times time, or t. While the equation for height is similar to distance or displacement. Height or h is equal to initial velocity, Vi, times time or t, plus 1/2 or 0.5, time acceleration due to gravity, times time squared or t squared. For the solution, again, all you have to do is substitute it. Therefore, the final answer is 25.48 meters per second for final velocity, or Vf, while 33.12 meters for height. Another sample problem is the Philippine tarsier is capable of jumping to a height of 1.5 meters in hunting for food. Determine the takeoff speed of the tarsier. Based on the problem, the given are 1.5 meters per second and the acceleration due to gravity is negative 9.8 meters per second squared. The required or what is being asked in the problem is the initial velocity, or Vi. It is also important to take note that at the highest point, the velocity of tarsier is 0. For the equation, initial velocity squared is equal to final velocity squared, or Vf squared, plus 2 times a or acceleration, times d or distance. For the solution, again, all you have to do is substitute it. Then, it needs to be computed using the square root to obtain the final result. Thus, the final answer is initial velocity, or Vi, is equal to 5.42 meters per second. Thank you, and I hope you learned something.